Hello, my name is Joshua Beard,
And I'm Shaylin Divins.
and we're here to tell you about our project for the 2016 AMALTHEA REU program.
For this video, we will be discussing Learning the Unheard, Identifying Infrasound Events. You may be wondering, what is infrasound and why are we studying it? Infrasound consists of low-frequency acoustic signals, typically those less than 20 Hz, which is below that of the human threshold for hearing. Common sources of infrasound can include seismic and volcanic activity and man-made events such as explosions. Our motivations are to enable us to identify nuclear explosions, predict seismic activity, and map volcanic plumes.
Our process consisted of three steps: pre-processing, feature extraction, and classification. Pre-processing is where we isolate the event, normalize the data, and filter out any high-frequency noise.
Then feature extraction is performed to extract the pertinent information about the signals that can be used for feature vectors later. We chose to implement two different feature extraction techniques. The first technique implemented was MEL frequency capture coefficients. Given a signal, it is divided into a number of overlapping frames. Then a series of mathematical transforms are used to obtain the spectrum. Given a pre-calculated filter bank, the filtered spectrum of the signal is computed, and then the energy captured by each filter is obtained. After a few more mathematical transforms, the mean of the value is taken and used to represent a feature in the final feature vector.
The second technique we implemented was the Hilbert-Wong transform. Given a signal, we decompose it into a number of integral components, known as intrinsic mode functions. We then apply the Hilbert transform to each of these functions to obtain instantaneous frequency vectors. The covariance among these frequency vectors is calculated and then used to compute the Cholesky decomposition, which gives us our final feature vector.
The final step is classification. Given the feature vectors obtained from 9 different classes, we used 3 different classification techniques: Fisher's linear discriminant, support vector machine, and k-nearest neighbor. As shown here by this bar graph, the final classification results show that HHT feature vectors performed poorly when compared to the results from MFCC feature vectors for all 3 methods.
In conclusion, we've determined that MEL frequency capture coefficients consistently produce superior results. Once again, my name is Joshua Beard,
And I'm Shaylin Divins.
and we would like to thank you for watching. Goodbye.